As we continue our unit on geologic history, it's important for us to determine the ages of different geologic features and rock layers that we could find throughout the world. The process of this is called relative dating, and it has absolutely nothing to do with dating your relatives. If you look at this image here of different rock layers, we're going to need to be able to determine which layer formed first, which layer formed more recently, putting these ages in order to determine the geologic sequencing. So the question that we need to know is, how can we compare the ages of these rock layers? So the process of relative dating is basically comparing the ages of these rocks and geologic events without knowing specific ages. So here is a very standard rock layer diagram with rock layers A, B, C, and D. And I am telling you that rock layer D is older than rock layer A. That's an example of relative dating. I'm not saying that rock layer D is 10,000 years old and rock layer A is 5,000 years old. There's no numbers involved. It's just a basic comparison: who is older, who is younger. Here's some more examples of the process of relative dating. So here we have a man and a woman, and if I were to compare their heights, all I need to say is the man is taller than the woman. We don't need to know their exact heights. All we need to know is the comparison that the man is taller, the woman is shorter. In another example, here we have a teacher and a student. The teacher is older than the student. The student is younger than the teacher. That's the concept of relative dating. You're not putting specific numbers to it. It's just a very simple comparison. So as we study geologic history throughout this unit, it's important for us to remember the law of uniformitarianism. This is a very fancy word for the present is the key to the past. So basically, all of the processes that we are experiencing on Earth today, we can assume that they operated the same way in the past. So if we know how things are working today, we can determine that these same processes also happened thousands to even millions of years ago. So the earthquakes that we experience today, volcanic eruptions, water erosion and the creation of waterfalls, hurricanes and other natural disasters, wind erosion and the formation of rock structures, and also glacial processes. All of these processes that we see happening right now, we also can assume that they happened in the past. And that's a really important idea because we weren't around in the past to know what happened, but the law of uniformitarianism allows us to make those assumptions that what we see now also happened long ago. So a geologic sequence is going to be the theme for the next few class days. Here is a picture of a rock road cut. If you ever drive in upstate New York, Pennsylvania, a lot of different places near us, you'll see these road cuts where you're riding on your road and to the right or the left, you see very distinct layers of rock. What you don't know is that these rock layers tell a very specific story that we're going to be able to determine how to read those stories in this class. The diagram on the right is something that you're going to be looking at more specifically, an example of a geologic sequence where we have rock layers A, B, C, or D that all tell a very specific story of how and when they formed. Here's another example of what we call a cross-section. This geologic sequence, we can look at these rock layers and figure out which formed first, which formed more recently, and what happened along their formation, because there's very specific clues that you'll be able to identify by the end of this lesson as well. So we're going to operate on a few principles today. The first principle is, how do we even form these rock layers? So the basic assumption that we're going to make is that sedimentary rock layers form as sediments are deposited at the bottom of a body of water. If you remember from the past two units, sedimentary rocks form from the compaction and cementation of sediments. And in the most recent unit, when we learned about deposition, when the sediments fall to the bottom of a body of water, they start to accumulate. And as they are accumulating, they get compacted and cemented together to form sedimentary rocks. So we need to understand that a lot of the rock layers that we're going to be analyzing in this class, the basic premise of them is that they're sedimentary in nature. So here's an animation that's going to show this example. Here we have a body of water, and at the bottom of that body of water, we're having the deposition of sediments, and the rock layers get built up over time. Rock layer 1, 2, 3, 4, and 5. Those all formed within a body of water below sea level. So that's how you get your basic rock layers to form. Principle number 2. Weathering and erosion. Well, once you have your rock layers formed, how do they get broken down and transported? Basically, weathering and erosion, they happen when the rock layers are above sea level and exposed to the environment, which makes sense because you need the wind and the water, the rain to conduct these processes of weathering and erosion. So the rock layers form below the water, and once they get above sea level and are exposed to the environment, that's when weathering and erosion can occur. So now let's take a look at the same animation, but take it one step further. After the rock layers are deposited in the body of water, other processes can happen. This is called folding and uplift. You can see that the rock layers were brought to a higher elevation. They were exposed above sea level. Weathering and erosion can then take over, and now look what happens. You can tell that some of the rock layers are missing. It's not complete anymore because weathering and erosion broke down the rocks and transported them away. So bottom line is sedimentary rock layers form below sea level. Once they're above sea level and exposed to the environment, that's when you get weathering and erosion. The next principle is called superposition. Superposition is one of the most important laws that we're going to need to understand, and it states that the oldest rock layers are found at the bottom of a geologic sequence, and the youngest, most recently formed, are on top. So here we have a layer of 4 different rocks. The oldest is rock layer 1, which is on the bottom, and the youngest, most recent, is rock layer 4 on the top. Our last principle for today is going to be one of our most important, which is going to bring us some really important examples, which is called original horizontality. The basic idea is that rock layers are deposited horizontally. If rock layers are not perfectly horizontal, it can be due to other processes such as folding, faulting, and tilting. So taking a look at this diagram, we have different rock layers, and all of them are perfectly horizontal. That's how they are formed originally when they are undisturbed, completely horizontal. So the question comes, what can cause rock layers to no longer be perfectly horizontal? If we look at this picture here of a mountainous environment, we can see that these rock layers are not perfectly horizontal. So mountain building is one reason that can cause the rock layers to no longer be originally horizontal. This can be done through the process of folding. So here we're back to the same animation, and if we look, the rock layers are perfectly horizontal. That's how they're originally deposited. But folding can cause the rocks to get uplifted in this case, and now they are no longer perfectly horizontal. You can see that there's a bend or a curve to these layers. So another piece of information that's important to understand is the process of folding leads to this process of uplift. Once these rock layers are folded, they get pushed higher up into the environment, so folding and then uplift will follow. Here's an example of folding in real life. If you look to the right of the man in the picture, you can see that the rock layers are curved to them. They're not perfectly horizontal, and this is because of a mountain building event, which ultimately led to uplift. Another example of what could make rock layers no longer perfectly horizontal are earthquakes. So here in this picture, we can see that there's a very specific divide on either side of where the earthquake happened. When earthquakes are powerful enough, it can completely break through the bedrock, causing a disruption to the rock layers. We call this process faulting. If we look at this image, there's 2 arrows, each facing each other. Right in the middle of those arrows, we have something called a fault line. And the fault line shows that the rock layers, or the crust of the earth, has been shifted over time because of this earthquake. So you can look and see on either side of that fault that the rock layers are no longer perfectly matched up. They're no longer perfectly horizontal because of that earthquake, because of that fault line that has developed. So we're going to end today with going through 2 examples of how we can conduct a geologic sequence. What you're going to need to do in this class is put geologic events in order from oldest to youngest, or more specifically, oldest to more recent. So let's go through this together. The first thing we need to recognize is in this diagram, we have map symbols that you can find on page 7 of the reference table. Don't forget that this exists inside of your reference table. When we learned about sedimentary and metamorphic rocks, we can represent these rocks in diagrams based simply on their map symbol, and that's something we're going to need to know for today. So to start, we need to think about the law of superposition. And to find the oldest rock layer, you're going to start at the bottom of the diagram. So if we look at the bottom, we're going to see here the first event was the deposition of sandstone. After the sandstone was deposited, the next is going to be the deposition of conglomerate. Then you have the deposition of shale, followed by the deposition of limestone. Now, if we look at these first 4 layers that have formed, we can see that they're no longer perfectly horizontal. This is a great example of folding. We know that the next thing that must have happened is these rocks were folded, but then after folding, you get uplift. You bring those rock layers above sea level, exposed to the environment. Now, if you look at the rock layers for shale and limestone specifically, you're going to notice that they're incomplete, that there's pieces missing. That's because after the uplift happened, we had weathering and erosion, which took some of those rocks and brought them away, so now that they are missing. What happens next is, in order to get new rock layers to form, you need something called subsidence. I want you to think of that first 3 letters of that word, first 3 letters of that word, subsidence. Think of sub like submarine. A submarine goes below the water. Subsidence means the same thing. You have to go below the water because after these rocks were uplifted, in order to get new rock layers to deposit, remember, you need to be below sea level. So subsidence takes the rock layers, puts them back below sea level, and then you get the deposition of limestone, and then the deposition of shale. Now, we're not quite done yet, because if you look at this top layer of shale, you'll notice again that there are some pieces that are missing. And again, that is due to weathering and erosion. So this is a complete example of a geologic sequence, putting all of these different events to create this diagram in order from oldest to youngest. Now let's just go through one more to make sure that we understand. So here we have a very different experience already. I can see that we have an earthquake involved because we have fault line XY, which we'll talk about very shortly. But to start this sequence, I'm going to go with my law of superposition and recognize that the oldest layer is on the bottom. So we have the deposition of conglomerate to start. That's followed by the deposition of limestone. Then we get the deposition of sandstone. And finally, we get the deposition of shale. Now, if you notice the rock layers above the shale, they are not impacted by this fault line that has developed. This fault line due to an earthquake only impacts those first 4 layers. So this must have happened next. Then you're going to see that on the left side of the fault line, the rock layers were shifted upward, while on the right side of the fault line, those rock layers were shifted downward. Only these 4 rock layers were impacted by that earthquake. So the next thing we put is the earthquake, which was fault XY. That earthquake led to some uplift, which then leads to weathering and erosion. After the weathering and erosion, we have more deposition of sandstone, followed by the deposition of shale. So when you're doing your activity today, make sure to go back to this video if you have any questions about the sequence of events that happen due to these geologic processes.